Okay, so a few thoughts. Obviously, before you work in a pipeline, you can have a business problem that can be turned into an ML problem. Sounds like a short, simple process. This is where people have the most trouble, actually, right? It's not in, retuning. It's not in data scrubbing and normalization or whatever you're going to do, pre-processing. It's not even, I mean, you might have some issues like finding data. That's common. But in today's age, with all the sensors and all the avenues in which we collect data, that's typically not an issue. But aligning business to problem, ML problem formation, that tends to can be a challenge. So let's talk a little bit about that. Like I said, we're only going to spend a few minutes on this, and then we're going to save the rest of it for tomorrow. So this is part 1. Okay. Defining the problem. So in this example, your first step in this phase is really just, let's just define the problem you're trying to solve and the goal that you need to reach. So let's say that we want to reduce the amount of unsold inventory that is left in stock. So some products are overstocked, some are understocked, leading to increased overhead costs and missed sales. Okay. So we want to reduce the amount of unsold because whether, right? If it's overstocked, we've got too much. It's understocked, we don't have enough. Let's just pick one aspect and say, you know what? Let's just reduce the amount of unsold inventory. So let's keep unsold inventory and missed sales low. So that would be like, for example, the specific goal or outcome that we're looking for in relation to this problem. And so our success metric, right? How do we define success from a business perspective for the goal? Is that we have to move from a qualitative statement to a quantitative statement, right? Something that's measurable, right? So SMART in a way, from the acronym SMART, right? And so it's a metric you could use to define success for this problem. At the end of the month, let's not going to have any more than 15% unsold inventory, right? Without running out. I mean, we don't want to run out. We don't want to get too low, but we also don't want more than 15% inventory. So somewhere between that, right? 1 and 15%. So now that we understand the business aspect, what is it that we're looking for? Like, how do we make this an ML problem? Like, what output do you want to see from the model that like would satisfy this goal, right? So you got to be specific. So it's got to like be like a model that excuse me. It's got to be a number that will fit the business goal, and it's something that ML can generate, right? I want to know the number of magical unicorns that will show up magically on Jupiter. It's like, yeah, okay, cool. Is that relevant to the problem? Let's figure that out. So it should be very specific to what we're looking at for. So in this particular case, how do we make it an ML problem? Well, in this case, for example, what we're looking for is that we want to predict like specific sales values for each of the items. So we want to try and predict the number of units that we're going to sell. By the way, is this first of all, is this a supervised and unsupervised or reinforcement learning problem? Or, maybe it's like, deep learning. What do we think this is? Okay. I'm not going to ask this question again because I feel like you probably know the answer. Why is it supervised? Because we've got historical data, right? We've got labeled historical data showing items selling, right? So in this particular case, we got supervised learning and we want to predict a number. Now, from our earlier examples around under supervised around basically binary classification, multi-class classification, and regression, when we're talking about a number, like which of these are we talking about? What kind of problem, right? It's a regression. Now, I know it says it on the page. Just want to make sure we're all on the same page, right? So we are trying to predict a number. How many units are we going to sell? What is the future demand going to be? It's a prediction, right? It's a statement about the future based on certain characteristics of the past. So most likely this is a regression problem. Now, you could also have a different need that could be a different kind of ML problem. For example, we might want to try to determine whether we should carry an item in stock at all, right? So you've decided to rule out any products that will have less than 100 sales. I feel like that's more of like a threshold exclusion, but whatever, right? You could actually just then run a different problem that says, hey, is this going to sell? Is this going to sell more than 100 units? Yes, awesome, let's keep it. No, it's out. Yeah. So then that might be a binary classification issue. Now, what if instead we wanted to determine the best month, right, to put each product on sale? Right? Swimsuits in winter, probably not the best time, right? There's some things, right, that are fairly obvious, but what if there's more subtleties to it? When do people start buying for the summer, as an example, right? I mean, we could look at past data to see what people actually did to sell it. And if we started selling a bunch of swimsuits in, just to say like in Georgia, it's like starts to get warm in like April, sometimes March, right? If people start buying swimsuits in March, that's probably a good time for us to put them on sale, right? Or maybe it's not, because we don't want to do it when sales are at peak, because there's a natural demand. Maybe we want to do it when sales are slumped. It just depends on what the business problem is. But we're trying to pick like a particular month, like which product would fit in which month. We're basically like putting a label on it. Which month out of the 12 are we going to put on this product, as far as like the best month to put it on sale? So I hope that gives you kind of an idea, at least from supervised learning, how to approach this. Now, it's important to avoid like overcomplicating the problem, right? And so frame the simplest solution. However, you also don't want to lose information, right? So, especially information that like in the historical answers, like for example, converting like an actual past sales number into a binary variable and like binning it and saying like more than 10 would lose valuable information. So you got to kind of invest time in deciding which target makes the most sense for you to predict from building models, especially ones that don't necessarily answer your question. So first is to define what kind of problem are you trying to solve? Are we yes, no classifying? Are we doing like a future state number as far as probability? Are we doing a multi-class classifier categorization? Now, from there, we got to get a little bit of understanding after we've defined like what kind of ML problem we're going for. How much data do we have and where is it? So let's go back to our original problem example of like predicting credit card fraud, right? We further formulated the problem, but what data do we need to actually train our model to reach the desired output and subsequently our intended business outcome? Like, do we have access to the data? How much data do we have? Do we have enough of it? Right? Do we have too much and need to do something like break it out into sets, right? Do we need to like centralize it because it's like scattered all over the place? Do we need to like format it in the same way? Like these are all questions, right? And let's talk about though the typical elements of like a data set first, right? Do you have the data you need, right? Is your data representative, right? So given what we know about the elements of an ML data set, you might need to get a domain expert, right? To quantify your data, understand things more contextually. Like for example, with our camera issue earlier, where we were looking at unsupervised data to detect like kind of anomalies, we might need a domain expert like who would come back and say, well, yeah, the cameras, go down for maintenance like once every 6 months, or maybe there's a local traffic enforcement or like city planner who maybe come back and say, well, we officially sanction races in the city and we close off the roads during that time frame, and therefore that's probably why you were seeing anomalies of 175 miles an hour, although that would be weird on surface streets, but let's throw that out there, right? So and this is an example when you're getting the data, like this is when it's valid in an ML pipeline to get domain expertise to really help answer the question, right? Is this data representative of the outcome, right? So with domain knowledge, you can begin to determine the features and the target data that your model will need, because your data should be representative of the data that you're going to have when you're using the model to make a prediction. So if you want to predict credit card fraud, as an example, because that's where we started, you're going to need both positive, like fraudulent transactions, one that are classified as fraud, and negative non-fraudulent transactions for it to be able to find pattern. If your actual amount of fraudulent transactions is 3%, but your training data set either includes like 10% of fraudulent transactions or like very small fraction, like 0.4, it's going to be hard for your model to truly learn patterns because your data set isn't going to be representative of what your actual like data set experience is. In other words, maybe globally across the country with the aggregate of all the data sets, you know that 3% is the actual total number of fraudulent transactions. But your particular data set is only a small subset and your fraudulent transactions are like 0.4%. It's going to be hard for your model to learn patterns related to fraudulent transactions that might counter out in the world if the training data doesn't have, you know, a similar distribution or greater, right? Greater is actually okay to a certain degree because then you can prune and do that, right? Remember, it doesn't have to be real world perfect, but it has to be better, right? Then, you know, it has to be trending towards better as far as like approaching the business outcome. I mean, if all of a sudden we were able to capture like 2% of the fraudulent transactions, but we still had to do the other 1% manually, that still might be headed in the right direction. So a domain expert can help qualify that as well. You also want to take a look at the quality of your data, right? Now, general rule of thumb here is that good data is going to contain a signal, something about like, you know, the thing that you're trying, the phenomena, like the thing that you're trying to model, right? For instance, let's say a wholesaler is trying to forecast demand for a few of their products. They might track the number of sales they had previously, which is like, you know, that's a good start. But what if they forgot to log when certain products were out of stock? If you're trying to forecast demand, it's important to know when you were out of stock and therefore critical to have that data to represent one of your features. Now, since this is numerical, could you look at other associated toothbrushes or other like associated products and see, could you look at other lotions and maybe get an associated value? There are techniques, by the way, for what they call imputation, you know, to either contextually or just by average, or there's a couple different ways to actually impute a value that won't skew your data too much, but that at the same time will be better than leaving it blank or nothing, because then that would throw it off. And you might be, well, Michael, can we just delete that data? What if that's an essential product, right? You shouldn't necessarily be so quick to prune data if there's techniques for you to impute a value that still allows you to generate a model, right? Now, your data is made up of two elements. And I think I mentioned this before, I'm going to say this again. A feature is an attribute of the data that can be used, like it's an attribute of your data set, right? That can be used to help identify patterns and predict future answers. So a feature like in this particular example with the credit card data could be the date of the transaction, the vendor, the charge amount, the customer. Now, here's the cool thing, like supervised learning, right? So we've got labeled data, right? So data for which we already know the answer, the outcome. This is the thing we want our model to predict. So the label here is that, was this fraud? No, it wasn't fraud. Was this fraudulent? Yes. Or then we got a question mark, which means we don't know, right? So in your training set, you definitely, right, you want to train it towards these outcomes. And so having labeled data basically allows you to verify whether this is true or not. Now, do you need a lot of labeled data? So the examples we've been talking about thus far, you know, obviously include labeled data, right? But if you don't have labeled data, for example, getting the labeled data that you need can be very arduous. Let's talk about like autonomous driving is a good example, right? Image data needs to be precisely labeled with where exactly the car is at any given moment. And it might be relative to some other object, like I'm relatively over here, I'm in the road, you know, signs, stoplights, other cars are all here, right? Without this labeling per se, the trained model might not be as accurate and could lead to potentially fatal mistakes. But there are other ways to approach this. So, you know, let me throw you off, because, you know, there are ways, at least in a virtual world, to train a model, for example, to navigate in virtual reality all these objects. And, you know, you can like do reinforcement learning, for example, in order to learn some of this. But I guess the point being is that depending on how you approach the problem, you will actually need a lot of labeled data, especially if it's a supervised model. Now, we mentioned this before, You can use SageMaker Ground Truth for generating labeled data. Again, you can use your own private workforce. You can use Mechanical Turk, which is super public, or you can get in with a vendor. If you want to create a contract with that vendor, you can do that as well. That includes NDAs and security lockdowns and stuff like that. But SageMaker is going to use a combination of a human selected workforce and machine learning basically to create a label data set. So it's going to give you access to a team of human labels that label your data, and it's going to feed that labeled data back to the service for automatic labeling. So think of it as a mix of like, you know, we get a couple of labels and then basically it labels the rest of your data based on that. And it goes back through a model in Ground Truth in order to get that data labeled once the human labelers have labeled a certain percentage of the data. So when generating the label data, the model sees how the humans label the data. So it teaches the model how they did it. And then it uses ML to learn where to add labels to unseen data to produce an accurate data set that's ready to use. So may have given you the impression earlier that was just 100% humans, but it's not, right? So type of workforce, publicly crowded, your internal work source, pre-approved third vendors, right? Now, this is probably a good place for us to stop. Because I was working on a just a quick demo of like submitting like a data set for Ground Truth, and they seem to be having some kind of problem because they've switched to automated labeling. Anyway, so this might be a good place to stop because the timing's perfect anyway. So in the morning, I'm going to show you just a quick demo of Ground Truth, hopefully with a completed data set, because it seems to have been stuck pretty much all day. And then so I'll do a little demo of Ground Truth. I will tell you, and I don't know why they did this, but they do have a tutorial that you can run through in your own free AWS account. Last time I checked, that running that tutorial, I think it costs you like $130. So I'm gonna run it again just to make sure. I would not run that. I'm sure like you're all like, yeah, $130, but I don't know that it'd be worth it just to do a Ground Truth exercise. So just know that's where we're going to pick it back up in the morning. But I would be very cautious around running that. I think at the last check, it was like $130 to run that tutorial that they've posted in there. So I already took a note and was like, I can't, well, I've asked them to take this out several times, but they kept it in there. So, okay. So for the time being, just in terms of how we've been defining the problem, labeled versus featured data sets, anything we've covered thus far, does anyone have any questions? Thanks, Jonathan. I appreciate your faith. Okay, good. So I'm going to pause this. So this is problem formation, like, part one. We're going to do part two tomorrow. We're going to finish this out. I'm going to pause it for the time being.